Welcome. In the last lecture, we successfully created this simple moving sprite, and I also left you two questions for you to think. So now I'm going to disable this real time, and I'm going to pause here for a few seconds. So try to compare your answers with the answers that I wrote, and don't worry if your answers vary from mine. Remember, your understanding will always be much more valuable. Alright, so in that lecture, we covered the spawn burst and spawn rate, and we also used the module at velocity. And later, for the VFX that we're going to create, we're going to heavily need these modules. So far, we can only spawn our particles at a fixed location, and generally, this is not something we want when we are creating other VFX. So in this lecture, let's look at what we can do about it. First, I'm going to go back to my Niagara basic folder, and I'm going to create another one. So for this one, I'm going to call it O3 shape location, and double-click to open it. Same as our previous lectures, in here, we need to create a Niagara system, and we need to place it in our level in order for us to see it. And there'll be your mini challenge today. So the challenge is, I'd like you to create a Niagara system using simple sprite burst. And after that, I want you to allow the particles to loop forever. Hopefully you still remember where you can set those things and where you can find this emitter template for us to use. And lastly, place your system onto a new demo display. Pause the video now and give this a go. I'm going to duplicate this demo display first. I'm going to change its name. I'm going to delete all these description tags. So click this icon to delete. And select this new system from selected image. And I'm going to select this simple sprite duration to forever. So to infinite, and the loop duration state, I'm going to change this loop behavior from once to infinite, and the loop duration is 2 seconds. Alright, that's enough. And I'm gonna also delete this spawn burst instantaneous. Instead, I like to use spawn rate, and I'm gonna give it a number of maybe 100, something like this. Alright, now we have 100 particles in here. Now under this particle spawn, first I'm gonna decrease their size. So instead of 50 here, I'm to think. So now I'm gonna go inside of this emitter state or this description, the emitters, and now, and I'm gonna select the simple sprite first and click finish. So for this one, I'm gonna call it NS shape location and double click to open it. So first things first, I like to set this particle to loop forever. So I'm gonna go inside of this emitter state. I'm gonna change this loop behavior from once to infinite. And the loop duration is 2 seconds. All right, that's enough. And I'm gonna also delete this spawn burst instantaneous. Instead, I like to use spawn rate, and I'm gonna give it a number of maybe 100. Something like this. All right, now we have 100 particles in here. Now under this particle spawn, first I'm gonna decrease their size. So instead of 50 here, I'm gonna change it to 10. And now all of those particles are spawned at the exact same location. I like to use the same module that we used in last lecture. So I'm going to click this button here, and I'm going to select this at velocity. And now you can see my particles begin to move. Now this isn't too ideal and very rare that we want our particles to spawn at the exact same location. So to change that, there's another module that we can use under this particle spawn stage, and that will be this shape location. So you can see, since it's already used very often, we can directly select it in this suggested module section. So I'm going to click that. And right after that, you can see all my particles are being separated. So by default, when you select this shape location, the shape primitive will be set to be sphere. So all of the particles will be spawned in a sphere. So I'm going to disable this real time here, so we can pause wherever it's happening inside of here, and we can change the sphere radius in here. So if currently I think the radius of this sphere is too large, I can decrease it down to maybe 50, and now I have a smaller sphere. I'm going to disable this and decrease it down to maybe 50, and now I have a smaller sphere. I'm going to disable this at velocity module for now. In order for us to smaller sphere, I'm going to disable this at velocity module for now, in order for us to see it better. So now you can see all the particles are being spawned in the sphere. This is one of the most used shape location for a VFX, but that's not the only one. So if you go to this drop down here, you can change this shape from sphere to other shapes. And depending on the VFX that you want to create, oftentimes selecting the correct shape location will be an important start. And below this shape location, you can see there are some other properties that we can set. So for example, we can change the sphere surface distribution. So this will determine where those particles will be spawned on the sphere. And also we can change the transform of this sphere. I'm not going to tweak those values for now, and I'm not going to go into these different shapes for now, because that will be your challenge today. So your challenge is, I'd like you to spawn your particles in various shapes, and more importantly, I'd like you to tweak the parameters for the shape you selected. So by adjusting those values of the module inputs, sometimes we can get a very interesting result. And don't worry if you find those values look intimidating. They'll become easier and easier as we use them more and more later in the course. Right now, just be comfortable with those values and with the names of those shapes. After that, I'd like you to spawn your particles in this shape. See if you can figure out which shape I use in here. And in order to achieve this result, I may have also used some other modules. And based on this picture, see if you can figure out which module might have been used. Alright, pause the video now and give this a go, or come back if you need help. Hey, welcome back. How did that go for you? Will you be able to create the shape that you desired? Now I'm gonna first enable this real time, so that my particle will begin to move again, and I'm going to go to this shape location. So instead of sphere, I'm going to change it to torus. And now you can see my particles are being spawned in a torus. Let's see what this will look like in our level. So go back to my level. I'm going to drag out this Niagara system and place it in my level. Also, I'm going to enable real time for my level. And now you can see all the particles are being spawned in a torus. But this is not quite the result that I want. I want this torus to face our camera. Right now, this torus is facing up. And that's not what I want. We can fix that by going back to our Niagara system. And we can change the rotation of this torus inside of this transform section. So if this is the only section that we want to see, we can click this button in here. In this rotation mode, instead of default, I'm going to change this to axis angle. And now you can see this shape has been rotated, but instead of a value of 1 in x-axis, this is the only section that we want to see. We can click this button in here. In this rotation mode, instead of default, I'm going to change this to axis angle. And now you can see this shape has been rotated, but instead of a value of 1 in x-axis, I'm going to change this to 0. And I'm going to give it a value of 1 in the y-axis. So now this torus will be facing our camera. So go back to my level. You can see now we have a camera facing torus. I'm going to drag it up a little bit, something like this. All right, in order to make this look more interesting, I'm going to go back to my Niagara system and I'm going to turn on this add velocity. So now my torus begin to move. And more than that, there's another module that I like to add inside of this particle update. So So you already know that using this scale color module, we can scale the alpha of the color. And since all the modules under this stage is being constantly updated, we can also scale the size of our sprite. And the name for the module is called scale sprite size. And you can see it's right there. After clicking it, by default, we'll have a curve that looks like this. So the size of our sprite will slowly increase depending on their lifetime, but this is not quite what I want. I'd like to adjust this curve. So there are two ways for us to adjust the curve inside of the Niagara editor. So first, we can directly adjust it in here. Or if you like to have a bigger viewport, you can click this icon here. So this will show this curve in the curve overview. After I click it, I can see my curve in here. And this is a much larger window for me to adjust this curve. First, I'm going to select this value. And instead of 0, I'm going to change it to 1. And now the size of my sprite will stay constant during their lifetime. And I'm going to select this key. I'm going to change its value to be 0. Now the size of my sprite will decrease. And this is a linear curve, but I don't want a linear curve. So for that, I can select both of these keys, press 1 on my keyboard. And now I can convert this curve into a more smooth one. And pressing the hotkey on our keyboard isn't the only way. You can also right mouse button click after you're selecting these two keys. So you can see 1 means auto. So we'll have a smooth curve. You can try out all these different options here, but oftentimes an auto curve is what we need. All right, I think this looks good enough. I'm going to go back to my level. And now we have a shape location. And same as always, our lecture today will end with a reflection task. So first question, I'd like you to write down the interesting shapes that you still remember from the module shape location. There are quite a few out there, and you can just write down a few that you think are interesting or will be useful in the future. And another one, I'd like you to write down something for the shape location and modules used here on this demo display. If you created a different shape in here, write down something about that, or it can be anything else that you think are more important. And we'll compare our answers in the next lecture. Now see you in the next lecture. Welcome! In the last lecture, we combined shape location and add velocity to create a Niagara system like this. And I'm going to pause the real time in here. So these are the answers that I wrote for the 2 questions that I left. Feel free to write down things that you think are important in here, as shape location is definitely something that we'll use very often in the future. Alright, after understanding the shape location, it's time we start to apply some forces to our particles during particle update in order to make our particles to look more interesting. To do that, I'm going to first duplicate this demo display. And for this one, I'm going to change its title from shape location to forces. And I'm going to delete these 2 sentences in here. And after that, I'm going to go back to this Niagara basic folder. I'm going to create another one. This one, I'm going to call it O4 forces. And double click to open it. I'm going to create a new Niagara system. As usual, I'm going to use this one. I'm going to call it all the settings, just like what we did before. So first, change this from 1 to infinite and delete this spawn burst and use this spawn rate instead. And give it a number of 100. And I'm going to decrease the particle size from 50 to 10. And I'm going to add the shape location right away. So this time I'm going to use sphere, and a radius of 100 is enough in this case. And going down to this particle update, I'm going to click this add button. You can see there's a drop down that says forces. And once we click it, inside of here, there are tons of forces that we can choose. After selecting any one of them, the force will be applied during particle update. And depending on the VFX that you want to create, usually we'll need multiple forces in order for it to work. As you can see, there are quite a few out there, but first things first, before I add any one of these modules, you can see in this protocol's update stage, there's this module called forces and velocity. As long as your Niagara emitter needs forces, you'll need this module. No matter which stage you add the force to this module, depending on the VFX, the force will drop down that says forces. And once we click it, inside of here, there are tons of forces that we can choose. After selecting any one of them, the force will be applied during protocol update. And depending on the VFX that you want to create, usually we'll need multiple forces in order for it to work. As you can see, there are quite a few out there, but first things first, before I add any one of these modules, you can see in this protocol's update stage, there's this module called forces and velocity. As long as your Niagara emitter needs forces, you'll need this module, no matter which stage you add the force to. So for example here, I'm going to add the module at velocity, and after that, I'm going to delete this module, and you can see my particles, they start moving, and after that, I'm going to delete this module. And you can see my particles, they start moving. In this module, we get a warning message. Here it says the module has unmet dependencies. So for any forces to work inside of this emitter, we'll need to use this module. So forces and velocity. So I'm going to click this button, fix issue. And now my particles start to move again. So the first module related to forces that I'm going to add is one that we'll use very often. So it's this curl noise force. After selecting it, now we still cannot notice a huge difference, so I'm gonna disable this add velocity. And you can see using curl noise force is the fastest way to provide randomness to the movement of our particles. So in here, for this module inputs, we can control the noise strength and the noise frequency. So say I now increase the strength from 10 to 100. And now my particles, they have a lot more randomness. And if I also take this at velocity, I'm going to decrease this at velocity. So instead of 1, maybe 0.5. So something like this. And besides this module, there are a lot of other modules that we can add. And you can find all of them under this drop-down forces. And that will be your challenge today. So your challenge is, I'd like you to use forces in protocol update stage. So same as our shape location, Try to tweak the values for the force you chose and try to see what they will do to your particles. Remember, you can always apply one or multiple forces to your particles. And the most important thing here is don't try to memorize all of them all at once. It's impossible for you to remember what each one of them will do, since there are quite a lot of them. As we use them more and more in the future, you'll find them easier to remember. For now, just try to be comfortable with them, be comfortable with the names, and be comfortable with adjusting all of those values. Alright, pause the video now and give this a go. Welcome back. How did that go for you? Hopefully you had fun in applying forces to your particles. Now I'm going to keep adding forces to my particles here. So first I'm going to disable this add velocity in order for us to see all the forces better. And the second one that I'm going to add is called drag. It simply slows down the velocity of our particles. So right now you can see the number for the drag is 1. So right after I say to 10, now my particles barely move. It seems like they're kind of floating, and they sometimes can create a very interesting result. So I'm going to lower down this value to 1, and for my curl noise force, I'm going to decrease it to maybe 500. Now I have more randomness. And another one that I think is very interesting is this vortex velocity. Another one, lower down this value to 1. And for my curl noise force, I'm going to decrease it to maybe 500. Now I have more randomness. And another one that I think is very interesting is this vortex velocity. So what this module is doing, let me just quickly show you. Now the velocity amount is set to be 200. I'm going to increase it to 2000. Now you can see my particles are rotating around you. This quick thing is this vortex velocity. So one that I think is very interesting is this vortex. Another one that I think is very interesting is this vortex velocity. So what this module is doing
So basically, when you click here or click here on the update and type vortex, there's a force, vortex force, but in previous version velocity that this is removed, vortex velocity module. So in UE5 this vortex velocity you can see I'm using here, and this is just rotating particle around like that. So this module is removed, and why it is important, it was important, and how it is different from the vortex powers. So let's check it out. So if I delete this, and I'll take the torus, and we have this torus maybe 200 radius. In here, in the particle spawn, what will happen? Just fix this, it will spawn these forces. So particle spawn, what will happen? Just fix this, it will spawn these forces. So particle like rotating around, but they are also like spreading. So they are not just rotating on a circle.
Let me just quickly show you. Now, the velocity amount is set to be 200. I'm going to increase it to 2000. Now, you can see my particles are rotating around the z-axis. So right now, the value for the vortex axis is 1 for the z-axis. And if I change the value to be 1 for the x-axis, now you can see my particles are rotating around the x-axis. And with the combination of increase the drag maybe to 10, and I'm going to also add the module scale sprite size. And instead of using this curve, you can select it from what's moved by default. So the curve that I'm going for that you cannot see, and now you can curves in like this. I'm pretty happy with this result. So, and drag it rotating around this. So I'm going to go back to my vortex velocity and set the x value to be 0 and set the y value to be 1. All right, it's for us to provide. Yeah, I'm pretty happy with the result in here. So first one, at which stage we want to apply the
They are so particle spawn torus, and if you take that vortex radius, it will spawn these forces in the particle spawn. What will happen? Just fix this, it will spawn these forces. So particle like rotating around, but they are also like spreading. So they are not just rotating on a circle, they are spreading also. And still, if you move this module here in the update, it will work the same. If you increase this, they will spread more. And that's why this force is different from this. So in here you can see this is just rotating on a torus shape. So this is this. So in here you can see this is just rotating on a torus shape. So this is different. This here in the update it will work the same. If you increase this, they will spread more, and that's why why this force is different from this. So in here you can see this is just rotating on a torus shape. So this is different. So how to
I'm pretty happy with the result in here. And our lecture today will end with two questions. So first one, at which stage we want to apply the force? Just to provide it more randomness, I'm pretty happy with the result in here. And our lecture today will end with two questions. So first one, at which I'm going to increase it to 2000. Now you can see my particles are rotating around the z-axis. So right now the value for the vortex axis is 1 for the z-axis. And if I change the value to be 1 for the x-axis, now if I change the value to be 1 for the x-axis, now you can see function of increase the drag, maybe more the size of change the value of this one. A lot of is this you can import other. All right, something like Niagara system fill time. And I think instead of rotating around the x-axis, I want my particles to rotating around back out, right? Something like this. I'm pretty happy. There are already a lot of curves being set for us. All we need to do is click it. So the curve that I'm going for is this one. See the two keys of yours, exactly the curve. A lot of time. Oh, go back to my left around the x-axis. I want my particles to rotate around you to be as 100 to 1000, something like that in here. And our lecture today will end. And with two questions. So first one, at which stage we want to apply the forces to our particles? And second one, what are the forces that you use in here? So you may have used a lot of different forces. Try to see if you still remember what are the ones that you use. I'll see you in the next lecture. Welcome. In the last lecture, we applied multiple forces to our particles, and as a result of that, we get particles like this. The forces that are used here to achieve this are control noise force, drag, and vortex velocity. Depending on your result, depending on the forces that you chose, you might have something completely different. But that's a good thing. Now, after understanding the sprite renderer, the shape location, the forces, the different particle stages, it's time we actually combine everything we've learned with GPU sprites. So, you already know that a sprite is simply just a camera-facing plane, and the reason why we can see spheres on our screen is because of the material that we use. And so far, we've only used what's called CPU sprites. First things first, all the particles, they are spawned on CPU. So the one on the left, this is CPU sprites, and the one on the right, this is GPU sprites. So the only difference between the two is CPU sprites are processed entirely on CPU, while GPU sprites are processed entirely on GPU. And one of the many good things for using GPU sprites is, with our GPU involved, we can process thousands more particles than CPU without causing too much of a performance hit. Now you might be wondering, then does this mean we should use GPU sprites all the time? Well, that's not the case, because certain modules are only available to CPU. If you choose a module that's not supported on either CPU or GPU, Niagara will usually give you a warning about it, so you'll see what they are when we encounter them. And with the GPU sprites and all those forces combined together, there are already a lot of interesting variations that we can create. So first, let's see how we can enable this GPU sprites. Go back to my level, I'm gonna duplicate this demo display again, and I'm gonna call this GPU sprites. And I'm going to delete these sentences. So go back to my Niagara basic folder. I'm going to create another one. I'm going to call this O5 GPU sprites, and double click to open it. Same as usual, create as our emitter. First, in order to use the GPU sprites, we can set it inside of these properties. So after clicking it, you can see the sim target here is set to be CPU sim. And in the drop-down here, we can change it to GPU compute sim. After doing that, you can see we get the warning message, and here it says missing fake bounce. So after changing the sim target to GPU compute sim, we also need to change this calculate bounce mode. So instead of dynamic, we need to change it to fixed. And now you can see that warning message is gone. And the reason for that is, after we set the particles to be processed on GPU, our CPU won't know the size of our particles. So it's important that we set it to be fixed bounce in order for everything to work perfectly. And if you click this drop down here, you can see this is simply just some hard-coded values for the bounce of our particles. Alright. Alright, I'm going to keep changing some of the settings for this emitter. So inside of this emitter state, I'm going to change it to infinite. And inside of this spawn burst instantaneous, now I'm going to change this number to be 3500. And now we have a lot more particles in here. And I'm also going to use the module spawn rate. And I'm going to change the number to 1000. So we'll be having 1000 particles that's spawned by this module, and another 3000 more spawned by this module. And this will completely kill our performance if this is a CPU sim. But luckily, we have GPU sim by this module. And I'm going to change the number to 1000. So we'll be having 1000 module, and this will completely kill our performance if a lot more particles in here, and 1000 module, and this will completely kill our performance if this is a CPU sim. But luckily, we have GPU sim. Now go to this initialize particle. For its lifetime, instead of direct set, I'm going to set it to be random. So I want some of my particles to live a lifetime of 3 seconds, and some of them to have a lifetime of 5 seconds. Alright, something like that. And for their size, I'm going to say it to be 1.5. And after that, I'm going to add another module. Since all the particles clustered together, I'm going to use shape location. And now you can see I have a lot of particles in here. So for the sphere radius, instead of 100, I'm going to decrease it to 15. And now they will all be spawned from this small sphere. Alright, that's everything that I want to set for this stage. Now moving on to this particle update. First thing first, I'm going to use the module scale sprite size. And I'm going to use one of the preset curve. So I like to use this one. Now their size will decrease throughout their lifetime, and I'm going to keep adding other forces. So next one, I'm going to add this curve noise force. And now things start to get interesting. So I'm going to change the noise strength from 10 to 125. There are no really specific reasons for me to use specific values, so feel free to use your own values. And for the noise frequency, instead of 50, I'm going to decrease it to maybe 25. Alright, something like this. And besides that, I'm also going to take this pen noise field and give it a value of 1 in the x-axis. This can provide us some more interesting variations. And I like to add another force, another module. So that module is called point attraction force. And I'm going to change this attraction strength from 1 to maybe 4, just to provide it more variations. And what this module is doing is simply attracting our particles. And you can see this point to attract is the particle's position, and this attractor position is this simulation position. So in other words, where our emitter is. And I'm going to also add drag, just to make it look more interesting. And now you can see I already have some interesting particles moving in here. And the last thing that I want to do is I like to set its initial color in here. But remember, this will only be run once. And after setting the color, there's a more powerful module, color. So note that, so you can only have one of these tender will override the module above. So by having, and this module will be a color module. So I simply need to change ages. We are static input to dynamic inputs that we can use. And usually all the suggested ones are enough for the things that we want to do. So I'm going to select this hints by default. So the ones that are above, these two, we can use them to control the. In 5.1, when you engine, it will add this pins means an opacity of 0. And this will be the color when the opacity is 1. So let's try to change that. I'm going to double click to open this pin, and you can see we get it okay. Now you can, and that's because as our particle lives in the word, its opacity is going to slowly into button click to add a pin. Now I'm going to change the color in here to something maybe greenish. From blue to one will be something yellowish. Alright, something like this, and I like to add another one here, so maybe this one, something red. And you can see, in this stage, we can barely see any red, and that's because, to this point, the opacity of our particle is fairly low, so we cannot see much of the red, but we can change that. We can add another pin in here for controlling the opacity. And right now, you can see the value is set to be 1. And after doing that, our opacity will only start to decrease at this point. Now we can see more red. Alright, I think I'm happy with the result in here. I'm going to go back to my level, and I'm going to drag in this Niagara system and place it in my level. And now we have some fairly interesting particles. And it's time for a challenge. So a challenge is simple. These are the modules that are used inside of this single emitter. So in order to use GPU sprites, you can go inside of this properties panel and change it. And it's simple. I'd like you to try creating something similar using GPU sprites. And these are the modules that are used inside of this single emitter. So in order to use GPU sprites, you can go inside of this properties panel and change it from there. And remember to set it to be fixed bounds. And after that, it's simply just applying forces, tweaking the values. So feel free to take a reference of this and try to create your own variation. And don't worry if your results vary from mine. Have fun with those values and try to experiment more. Alright, pause the video now and give this a go. Fairly interesting results. And click to open my system. Now I like to increase the brightness of it a little bit. And to do that, it's fairly simple. With this gradient editor, we can just double click to open this color picker. Go to the spot where it says V. So here, V means value. Instead of 1, I'm going to change it to 5. Now you can see the brightness of the blue has increased significantly. And I'm going to also be doing the same thing for the green. So instead of 1, maybe 3. And for the yellow, I'm going to change it to maybe 2. And for the red, maybe 3. I'm just picking the values randomly, so feel free to experiment with your own values. And now I think this looks fancier than what I had before. So after using the GPU sprites and combined it with multiple forces, this is what we can come up with. And now if you go inside of this Niagara system, this new system from selected emitters. And if you look at all of these templates again, these are just a bunch of pre-built emitters that contain some preset modules. Take this fountain emitter for example. So in order for our particles to move like a fountain, so maybe it needs a very specific shape location, it needs some very specific forces module, and same thing goes for this hanging particle, this simple looping particle. So feel free to dig in to see what these templates could do. And now, with the knowledge of what we have so far, and with all those existing templates, there are already a lot of VFX that we can create. And in the next lecture, we'll see how we can do that. And our lecture today will end with a reflection task. So try to think about these 2 questions and write down your own answers. So question 1, when to use GPU sprite? And number 2, what are the forces that you use to pull this effect off? So if you have used different forces modules, feel free to write them down here or anything else that you think are important. Great job. I'll see you in the next lecture. of particles in here. So for this mode, so instead of dynamic, we need to change it to fixed. And now you can see that warning message is gone. And the reason for that is, after we set the particles to be processed on GPU, our CPU won't know the size of our particles. So it's important that we set it to be fixed bounds in order for everything to work properly. And if you click this drop down here, you can see this is simply just some hard-coded values for the bounds of our particles. Alright, I'm going to keep changing some of the settings for this emitter. So inside of this emitter state, I'm going to change it to infinite. And inside of this spawn burst instantaneous, now I'm going to change this number to be 3500. And now we have a lot more particles in here. And I'm also going to use the module spawn rate. And I'm going to change the number to 1000. So we'll be having 1000 particles that's spawned by this module and another 3000 more spawned by this module. And this will completely kill our performance if this is a CPU sim. But luckily, we have GPU sim. Now go to this initialize particle. For its lifetime, instead of direct set, I'm going to set it to be random. So I want some of my particles to live a lifetime of 3 seconds and some of them to have a lifetime of 5 seconds. Alright, something like that. And for their size, I'm going to say it to be 1.5. And after that, I'm going to add another module. Since all the particles clustered together, I'm going to use shape location. And now you can see I have a lot of particles in here. So for the sphere radius, instead of 100, I'm going to decrease it to 15. And now they will all be spawned from this small sphere. Alright, that's everything that I want to set for this stage. Now moving on to this particle update. First thing first, I'm going to use the module scale sprite size. And I'm going to use one of the preset curve. So I like to use this one. Now their size will decrease throughout their lifetime, and I'm going to keep adding other forces. So next one, I'm going to add this curl noise force. And now things start to get interesting. So I'm going to change the noise strength from 10 to 125. I'm going to change noise force, and I'm going to keep adding other forces. So next one, I'm going to add this curl noise force. And now things start to get interesting. So I'm going to change the noise strength from 10 to 125. There are no really specific reasons for me to use specific values, so feel free to use your own values. And for the noise frequency, instead of 50, I'm going to decrease it to maybe 25. Alright, something like this. And besides that, I'm also going to take this pen noise field and give it a value of 1. In the x-axis. This can provide us some more interesting changing some of the settings for this emitter. So inside of this emitter state, another one. I'm going to call this O5 GPU sprites. And double click to open it. Same as usual, create a Niagara system. Choose this simple sprite burst as our emitter and name this to GPU sprites. And double click to open it. So first, in order to use the GPU sprites, we can set it inside of these properties. So after clicking it, you can see the sim target here is set to be CPU sim. And in the dropdown here, we can change it to GPU compute sim. After doing that, you can see we get a warning message, and here it says missing fixed bounds. So after changing the sim target to GPU compute sim, we also need to change this calculate bounds mode. So instead of dynamic, we need to change it to fixed. And now you can see that warning message is gone. And the reason for that is, after we set the particles to be processed on GPU, our CPU won't know the size of our particles. So it's important that we set it to be fixed bounds in order for everything to work properly. And if you click this dropdown here, you can see this is simply just some hard-coded values for the bounds of our particles. Alright, I'm going to keep changing some of the settings for this emitter. So inside of this emitter state, I'm going to change it to infinite. And inside of this spawn burst instantaneous, now I'm going to change it to infinite. And inside of this spawn burst instantaneous state, I'm going to change it to infinite. And inside of this spawn burst instantaneous, now I'm going to change this number to be 3,500. And now we have a lot more particles in here. And I'm also going to use the module spawn rate. And I'm going to change the number to 1,000. So we'll be, and I'm going to change the number to 1,000 spawn rate. And I'm going to change the number to 1,000. So we'll be having 1,000 particles that's spawned by this module and another 3,000 more spawned by this module. And this will completely kill our performance if this is a CPU sim. But luckily, we have GPU sim. Now go to this initialize particle. For its lifetime, instead of direct set, I'm going to set it to be random. So I want some of my particles to live a lifetime of 3 seconds and some of them to have a lifetime of 5 seconds. Alright, something like that. And for their size, I'm going to set it to be 1.5. And after that, I'm going to add another module. Since all the particles clustered together, I'm going to use shape location. And now you can see I have a lot of particles in here. So for the sphere radius, instead of 100, I'm going to decrease it to 15. And now they will all be spawned from this small sphere. Alright, that's everything that I want to set for this stage. Now, moving on to this particle update. First thing first, I'm going to use the module scale sprite size. And I'm going to use one of the preset curve, so I like to use this one. Now their size will decrease throughout their lifetime, and I'm going to keep adding other forces. So next one, I'm going to add this curl noise force, and now things start to get interesting. So I'm going to change the noise strength from 10 to 125. There are no really specific reasons for me to use specific values, so feel free to use your own values. And for the noise frequency, instead of 50, I'm going to decrease it to maybe 25. Alright, something like this. And besides that,
We create a spot to part.
I'll just right click, and if I go here and then I'll just delete the gravity I don't need, and spawning too much random move how this frequency just make go better with 20 add value so particles is and velocity all gravity I don't add the fountain. I'll just right click and add an emitter. I'll take the fountain, and today's force is favorites. Gravity I don't, and we have the particles affecting to move in a random movement. Frequency work linear and just 100. Noise. It's a frequency, and then okay is 5. Say if you require at all.
I'm also going to take this pen noise field and give it a value of 1. I'm going to decrease from this small sphere. Alright, that's everything that I want to set for this stage. Now, moving on to this particle update. First thing first, I'm going to use the module scale sprite size. Adding other things start to get in. Next one, I'm going to add this curve noise force, and now things start. So next one, I'm going to add this curve noise, this one. Now their size will decrease. Throughout their lifetime, and I'm going to keep adding other forces. So next one, I'm going to add this curve noise force, and now things start to get interesting. So I'm going to change the noise strength from 10 to 125. There are no really specific reasons for me to use specific values, so feel free to use your own values. And for the noise frequency, instead of 50, I'm going to decrease it to maybe 25. Alright, something like this. And besides that, I'm also going to take this pen noise field and give it a value of 1 in the x-axis. This can provide us some more interesting variations. And I like to add another force, another module. So that module is called point attraction force. And I'm going to change this attraction strength from 1 to maybe 4, just to provide it more variations. And what this module is doing is simply attracting our particles. And you can see this point to attract is the particle's position, and this attractor position is this stimulation position. So in other words, where our emitter is. And I'm going to also add drag. Just to make it look more interesting. And now you can see I already have some interesting particles moving in here. And the last thing that I want to do is I like to set the colors for my particles. And there are 2 spots for us to do that. So first, we can set its initial color. Inside of this initialized particle module, so we can directly change its color in here. But remember, this will only be run once, and after setting the color, we cannot change it inside of this stage. And inside of this particle update, there's a more powerful module that we can use. So I'm going to click this add button, and I'm going to add the module color. So note that we have two modules related to color here. One is this color, one is this scale color. So you can only have one of these two. So you either have scale color or you have color. Whichever module is under will override the module above. So by having the color module below, we no longer have the scale will be constant. And to do that, when we add the module, we can change the static the available dynamic inputs that we can use. And usually all the suggested ones, you can see we get this grid that we want to do. So I'm going to select this color from curve. And you can see we get this gradient map. And there are 4 pins by default. So the ones that are above, these two, we can use them to control the color. And the ones below, these are the pins that related to opacity. In 5.1, when your mouse hovers over it, it doesn't tell you what this is doing. But I'm going to double click to open this pin, and you can see we get a okay fade opacity and such, right? Because to this point, the opacity of our particle is fairly low, so we cannot see much of the red, but we can change that. We can add another pin in here for controlling the opacity. And right now you can see the value is set to be 1. And after doing that, our opacity will only start to decrease at this point. Now we can see more red. All right, I think I'm happy with the result in here. I'm going to go back to my level, and I'm going to drag in this Niagara's early inch. I like use all it's to be. Feel free to take away from it. There's one more system. Now this grid says V, so here V means click to open this color picker. Go to significantly 3. And for the yellow, E3, using the GPU sprite, I think this looks fancy. fancier than what I had before. So after using the GPU sprites and combined it with multiple forces, this new system for a bunch of for example, fixed shape hanging particle, this existing template will try to think to use GPUs will here or anything else that you think are Welcome! In the last lecture, we successfully created this VFX using different forces combined with our GPU sprites. So far, we've only been using the sprite material
useful thing because I'll just right click and add an emitter. I'll take the fountain.
For the particles that we created. And there are so much more that we can create when we apply our custom materials to all of those particles. In this lecture, let's look at how we can create some custom materials. So first things first, we'll need to have some textures. And luckily for us, there are already a lot of stunning textures prepared for us. We just need to know where to get them. So the first path of texture that I'm going to get will be from this VFX pack. You can see this is a free pack, so it's called Realistic Starter VFX pack. Inside of it, there are a lot of VFX that's made using the old VFX system, the Cascade particle system. We are not interested in those, but with the textures this pack can provide, we can use Niagara to create something much better. So I'm gonna first add this pack to my project, and you can see by default this pack already supports 5.1. So I'm gonna click Add to Project. Alright, after adding this VFX pack, the only folder that I'm interested in is this textures folder. So you can see inside of it, there are a lot of decent textures that we can use. So I'm going to copy out this folder, and then I'm going to delete this pack. So first, I'm going to go back to my content folder. Inside of it, I'm going to create a new folder. I'm going to call this one textures. And right away, I'm going to copy out this texture folder. So I'm going to select this folder, and I'm going to drag it to my own texture folder and select copy here. And after that, I'm going to go to File and click Save All. Then I'm going to rename this folder to realistic_VFX texture. And these are all the textures that we can use later. And next thing, I'm going to delete this VFX pack. So I'm going to select it and right mouse button. Click and choose delete and just click delete in here. Alright, now that we have the textures ready, next thing we need some materials. So I'm going to go back to my content folder, I'm going to create another one, and I'm going to call this material. And double click to open it. Right mouse button click, I'm going to select this material, and I'm going to keep its name a default. I will change that later. Double click to open it, and this is the default interface that we'll see. So first, I'm going to bring in the texture that I'm going to use later. So you'll be from this realistic VFX textures. And the texture that I like to use is this T_dandelion. So I'm going to drag it into this viewport and place it in there. Alright, which socket should we plug in order for this VFX material to work? So in order for a material for VFX to work, there are quite a few settings that we need to set. This is the default sprite material that we've been using. You can see this is simply just a white dot. And in order for this white dot to work, there are 3 settings that we need to set. So first, we need to have a correct blend mode. And second, we need to have a correct shading model. And last one, we also need to have this two-sided option ticked. Let's go over these options one by one. So here I am inside of the material editor. I'm going to click this new material, and you can see in here, there are some settings that I can set. So the first thing that we're going to set is this blend mode. After I click this drop down, you can see there are plenty of options that we can choose. So for VFX material, the most commonly used blend modes are translucent and additive. But which one should we choose in here? Well, to answer that question, we first need to know what's the difference between the additive and translucent. As you can see here, I have 2 sprites. They have the exact same size and they are using the exact same material, except one of them is using the additive blend mode, another one is using the translucent blend mode. So just by looking at them, can you tell what difference do they have? Maybe right now you are thinking, well, they don't look too different to me. And you are correct. But once I start to change their colors, things will change. So for these 2 sprites, same as above, they are using the exact same color. But you can see we get a quite different result in here. So the particle, the sprite on the left, this is using the additive blend mode. And the one on the right, this is using the translucent blend mode. When dealing with the VFX material, this is the biggest difference of these 2 blend modes. So for the additive blend mode, when dealing with colors, the black color will just render as transparent, while in this translucent blend mode, we can actually show darkening colors. And there will be times that we need to have some dark colors inside of our VFX. And if that material that we're going to apply black colors to is using this additive blend mode, then we won't be able to see any dark colors. And if our VFX only needs bright colors, we can just stick with this additive blend mode. So go back to my material editor. First, I'm going to change this blend mode from opaque to additive. So for my dandelion, I don't need any dark colors. Alright, that's the blend mode done. And next thing that we need to set is this shading model. So by default, it has been set to default lit. And most of the time, default lit is what we'll be using inside of Unreal Engine for PBR material. So for default lit, it can cast both shadow and light. But for a VFX material, we want this to be unlit. So inside of this shading model, it does not cast any shadow or light. And this is perfect for a VFX material. So I'm going to change this shading model from default lit to unlit. And you can see after that, we have access to only a few sockets. And the one that we'll be using all the time are this emissive color and opacity. Now, the socket emissive color is easy to understand. We just need to plug the color information inside of it. But why do we need this opacity socket? Let me just quickly show you. So now I'm going to plug the RGB information of this texture into this emissive color socket. And I'm going to change my preview mode to this plane. And you can see this is our dandelion. I'm sure you can notice that the result here isn't too ideal. And that's because we only want this dandelion in the middle. We don't want this background. And to get rid of that, we need to access the opacity socket. In other words, we need to understand what will be rendered as transparent and what will be rendered as opaque. To quickly show you an example, I'm going to hold down 1 on my keyboard to bring out a scalar. So this is just a single value. I'm going to first set its default value to be 1 and plug this into emissive color. And now you can see we get a Y plane. So colors, they're just values, and a value of 1 will get us this white surface. And I'm going to change the value to be 0. And we cannot see anything for now. So theoretically, we should be seeing a black surface, but why can't we see anything at this moment? Think about that. What's the reason for it? Alright, hopefully you still remember. Currently, we are under this additive blend mode, and inside of this mode, any black color will just be rendered as transparent. So in order for us to see the black, I'm going to change that from additive to translucent. And now you can see, we can see a black surface. That's the color for a value of 1 and a value of 0. And once I plug a value of 1 into the opacity, you can see we can get a totally opaque surface. And when I change the value from 1 to 0, you can see we get a completely transparent object. A value of 0 means transparent and a value of 1 means opaque. And going back to our texture, so we need to have some kind of pattern that only has white in the middle and has black for the background. So let's double check this texture to see in which channel we can get such a pattern. So I'm going to click this magnifying glass and it will take me to where this texture is located. Double click to open it. So you can see for this texture, it has alpha channel, and usually inside of the alpha channel, it has the value we need. So I'm going to first mute the 3 channels first. So I'm going to disable RGB channel. And you can see for this alpha channel, we have the exact values we need. So only white parts for this center line and black for this background. Using white values to show certain parts, using black values to hide certain parts, that is also known as a mask. And this is the mask we need. Go back to my material, I'm going to plug this alpha into opacity. And now we have our dandelion. But we still need one more node to set up this VFX material. So when we use this material instead of VFX, oftentimes we want to alter its color. We will want to alter its opacity. Sometimes maybe we want to scale its alpha to slowly fade out this particle. And for that, we'll need to have another node. So it's called particle color. The 2 pins that we need are this RGB and this alpha. We can combine the RGB information of these 2 nodes together by using a multiply node. So you can hold down M on your keyboard to bring out a multiply node. I'm going to plug this RGB into A and plug this RGB into B and plug the output into emissive color. Now, whatever changes we make to colors inside of our Niagara system will affect this material. And for the alpha channel, we can use the same method to combine them together. So I'm going to hold down M on my keyboard and plug the alpha into A, plug this alpha into B, and plug this into opacity. And that's it. This is the most basic setup for a VFX material. And it's time for a challenge. So your challenge is, I'd like you to import the texture pack from this realistic starter VFX. Same as I did, you can just copy the texture pack from it. And after that, you can just delete this pack. And after getting hold of the texture that you need, create a material for our VFX. Be careful with all the settings and feel free to refer back to the video if you need help. Pause the video now and give this a go. Welcome back. How did that go for you? Hopefully that was easy enough for you to do. After creating this material, I'm going to rename it. So same as our folder structure, having a fixed naming convention for our assets is very important in here. So I'm going to call this material m_single texture master and underscore additive. So this will be the master material for all the future VFX that we're going to create, if that VFX will be used as a texture parameter. In this material, that we can translucent material, it translucent to me, we get mode with the default, it has been set to default lit. And most of this shading model, so by default, we'll after that we this image we'll pass this text with this result here isn't this where we get a white plane. So colors that change, I think remember the black. I'm gonna check surface a value of totally opaque into value of it's white. Let's see for the value we say using plug this out to scale its alpha to slowly fade out. We'll need to have another node, so it's called particle color. The two pins that we need are this RGB and this other, but I'm going to plug this RGB into A. And plug this we make two colors inside of our Niagara, and that's it. This is the most basic as I pause the video now and give this a go. Easy enough for you to structure. So master all the underscore additive. So this will be the master material for all the future VFX that we're going to create. If that I will be instance, a texture parameter. And I'm going to call this texture sample node into a texture parameter. And I'm going to call this parameter main texture. And I'm going to hit apply, and I'm going to right mouse button click to create a material. Instance. So for this material instance, and the last thing that I want to do is I'm going to click this node and I'm going to take this two-sided option. So if we're only going to be using this material for a sprite renderer, we might not need to take this, but we might also want to use this on a custom static mesh, and there will be times that we want to look at the mesh from the back. So if we don't take this, we just won't be able to see anything from the back of the mesh. All right, I'm going to click apply. And that's the basic setup for the material done. And in the next lecture, we'll look at how to set up our Niagara system. In this lecture, we went through the materials blend mode, and we also talked about the shading model, and we also covered the importance of the opacity socket for VFX material. Well done. see you in the next lecture. Welcome. In the last lecture, we created this material instance for us to use. And in the future, if we need to use this material again, we can just create another material instance and swap out this texture. In this lecture, let's look at how we can use this material to create a dandelion effects. So first, I'm going to go back to my Niagara Basic folder, and I'm going to create a new folder. I'm going to call this one 06 Dandelion, and double-click to open it. So right away, I'm going to create a Niagara system, and click Next. So if we want, we can build everything from ground up. We can set up the particle size, we can set up the spawn location, and add those different forces modules. Or we can use one of the existing templates to help us achieve what we want. So if you scroll down, you can see there's this emitter, and it's called hanging particulates. And this is perfect for what we want. We can see all the particles will be swirling in a rectangular area. So I'm going to select this one and click this add button, click finish. So I'm going to name this to ns_dandelion and double click to open it. So you can see this is what this emitter template is doing. And if we look closely at these different modules, so under this emitter update, these two are the one that we've used quite a lot. And under particle spawn, these two, if we look close, so you can see this is what this emitter template is doing. And if we look closely at these different modules, so under this emitter update, these two are the one that we've used quite a lot. And under particle spawn, these are the two modules that we know. One thing to look for here, inside of this initialized particle, the sprite size has already been set to be random, and the sprite rotation mode has already been set to random as well. And this is perfect for our dandelion effect. If we don't use random and use unset instead, all the dandelions will be facing the same direction. And under this particle update, there are some forces module that we haven't seen before. So number one is this wind force. I think this name is already clear enough. By using this module, we can apply wind to the particles spawned by this emitter, and we can adjust its scale in here. And there's another module, so it's called aerodynamic drag, and this is newly introduced to Unreal Engine 5.1. And comparing to the old drag that we used, this is more of an upgrade version, and it gives us more control, and it achieves a better result. And other than that, it has this scale sprite size. This is its curve. So you can see the size will increase to its max size, then it will hang there for quite some time, then it will decrease it to 0. And we also have this scale color. So all it's left there to do is to swap out this material. So we need to use our own material in here. Go back to my content browser. I'm going to move that material instance to this folder. So go to my material. I'm going to select this material instance and drag it to this dandelion folder and select move here. I highly recommend you to do the same to put every asset related to your Niagara system into one same folder. This is just in case in the future, if you want to revisit some of the VFX, you don't need to jump around between different folders, because you might have some textures in another folder, some materials in a folder, and in order for you to see everything, it will be quite time consuming once the VFX is complicated. Alright, your asset related to your Niagara system into one same folder. This is just in case in the future, if you want to revisit some of the VFX, you don't need to jump around between different folders, because you might have some textures in another folder, some materials in a folder, and in order for you to see everything, it will be quite time consuming once the VFX is complicated. Alright, I'm going to open this Niagara system, and I'm going to select this material and click this icon to use it. And I'm going to select this material and click this icon to use it. And wait for the shaders to be recompiled. And now you can see we have some dandelions, but we have some issues. You can see the size of it is way too small. I'm going to drag it out in my level first for us to better see it. So go back to my level. You can see we already run out of slots, and I'm going to increase some slots in this room. So after selecting this room, I'm going to increase this length from 5 to 10. And I'm going to duplicate this demo display, and I'm going to name it to dandelion. Alright, I'm going to drag out this Niagara system and place it in my level. And you can see this is what we get. So the scale is a bit off, and in order to get a better sense of it, I like to get a reference. So I'm gonna go to the spot where I'm using this mannequin, select it, and since I'm moving it to a spot that's outside of my field of view, I'm gonna hold down Shift on my keyboard. So my camera will follow along this moving. And drag it to the Niagara system. And inside of this initialized particle, we can tweak these two values in here, and then go back to our level and see what it looks like. Or we can just convert these two values into user parameters. By doing that, we can directly adjust these two values in our viewport. To do that, it's fairly simple. We just need to click this button, and in here, I'm gonna type user parameter, and you can see it's right there. Here it says read from new user parameter. I'm gonna click it. Now this value has been converted into user parameter, so this will be the minimum value for the scale of the sprite. I'm gonna be doing the same thing for this sprite max. So I'm gonna click here and type user. And click this new user parameter. Now I have two user parameters. In order to find them inside of our Niagara system, you can go to your left. You can see there are 3 tabs in here, and we have 2 user parameters in here. And the best thing about it is, if we now go back to our level, I'm going to press G to show this icon. You can see now we can direct it out to, you can see we have much larger than the max scale to 9. Now you can see we have much larger than the lines. So this looks alright, but we can make it much better by tweaking some of the values inside of the system. And that will be our first section challenge in the course. So the challenge is, I'd like you to assign our custom material to this existing template hanging particles. And after that, I'd like you to tweak the values inside of it so that you have a better than the line effects. So maybe the wind force is not strong enough, or the drag is a bit much. Try to use dynamic inputs to give yourself more random values to make these effects better. And remember, user parameters can surely help you to do this. Pause the video now and give this a go, or come back if you need help. Effects that you create. Now I'm going to tweak the values for my effects. So I'm going to open this Niagara system. First, I'm going to change it from CPU sprites to GPU sprites. In case I want to increase its, I'm going to change it and tweak the value. values for my effects. So I'm going to open this Niagara system. First, I'm going to change it from CPU sprites to GPU sprites. In case I want to increase its number significantly, so I'm going to take this GPU compute sim and change its bounds to fixed. Then under the spawn rate, instead of a static value, I'm going to convert it to a dynamic input. So I'm going to select this random range float, and the value that I'm going for will be something like 80 and 100. All right, something like this. And instead of this initialized particle, I like to keep everything at default. And this shape location, using a box, is perfect for this kind of at default. Like this. And instead of this initialized particle, I like to keep everything at default. And this shape location, using a box, is perfect for this kind of effects, but I like to convert this value into a user parameter. So I'm going to click this button here and type user and select it. So the box size will be something that we can control in our level. And I'm going to go to this wind force. So for the wind speed scale, I'm going to use a random range float. And I'm going to change it to be a value between 3 and 5. And for this turbulence, so I like to have a stronger value. I'm going to use a random range flow as well. So the value I'm going for will be somewhere between 6 and 8. I'm going to keep this aerodynamic. The value I'm going for will be somewhere between 6 and 8. I'm going to keep this aerodynamic drag at default, and this scale sprite size at default, and this scale color. So I don't want my dandelion to fade in then fade out. I like to use this curve instead. Alright, go back to my level. This is what I have so far. I'm going to decrease their size a little bit, so maybe somewhere between 5 and 7. And I'm going to decrease its box size a little bit, between 5 and 7. And I'm going to decrease its box size a little bit, so maybe somewhere between 300. Alright, something like this. And because this is a sprite renderer, no matter where we are in our level, these sprites will always be facing us. And this is a relatively cheap effect, but With some custom materials, we can get a quite decent result. What's your design effect like? Is it something similar to mine, or did you create a much better one? Go share your effects in the Discord channel, and I'll see you in the next lecture.